So this problem is again related with the projectile. In this case, the object is thrown at an angle theta from a cliff with a certain velocity. You give it the time, and your task is to find out the height of the cliff and the horizontal range and what is the velocity. So let me explain this problem here. So this is the height, this is the cliff. Let's say the height of the cliff is h, and this is moving at 25 meters per second, and this angle is theta, and it is thrown at an angle theta. So when it hits the ground, it's not going in a straight line. It will be coming in a parabolic motion. Okay. So what is the height of what is the height? You given the time. The time to reach the ground is 3.75 seconds. This is the time. Okay. And then you need to find out the height. So let's start this problem here. So the way this problem can be divided into is you have this velocity. You can divide this velocity into two components. One along the x component, and the another is along the y component. So what is the x component? v0x. Here. So this angle is theta. So the y component would be v. This velocity is v. Would be cosine theta, because this angle is given theta. And so the v and this component will be sine theta. So v0x, v sine theta. Remember, if this angle is closed, if this angle is theta, this is always cosine theta, and further from the angle is sine theta. If this angle is theta, closer is cosine, and further is sine. So this is v0y would be v cosine theta. So the velocity is 25. Cosine theta, the sine is 40 degree. Sine 40 degree. So when you solve this equation, it will be 16.1 meter per second. This x component, and the y component is 25 times cosine 40 degree. So you just have to use your calculator. When you do that, you will get 19.15 meter per second. Okay. So we find out the x component and the y component. Now we need to find out what is the height of the cliff. Again, we can separately think these two problems. We can divide this problem along x component and along the y component. Okay. So in order to find the time, we'll be thinking about the motion in the y direction. Now let's think about the y direction. The y direction is the vertical direction. We're given the time as well. The time is 3.75. So in y direction, we given the height and we given the time. So I can use S is equal to ut plus half gt squared to find my height, because we given the time and we already know the velocity. Okay, so this is height h, and this is the vertical velocity. This is the vertical velocity, which is 19.15. 19.15. The time is 3.75 seconds. 3.75 seconds plus half g is, you know the value of g, which is 9.8, and the time is 3.75 square. So just do your math, and the height you will get is 141 meter. This is the height. We found out the height now. The next thing is you need to find out the horizontal range. When I say the horizontal range, it's this, you need to find it out in the second part. We call the horizontal range. Okay. So how do you know that? In order to calculate this distance, you need to know the time. You already know the velocity. So all the information you need to know is already given there now. Now let's see. Let me find some space here. I'm just plugging using this point here. Here, along x-axis. Remember, this is x and this is y-axis, or this is the downward. When they say this is a y-axis, along y-axis, x-axis. Along this direction, the s is equal to velocity times time, because there is no any acceleration along the x-axis, and this is r. The horizontal velocity is 16.1. You see the horizontal velocity because we're just taking this velocity along this axis, and the time. And the time, we already know that this is 3.75. So just plug in here. So once you plug in, you will get 60.4 meter. 60.4 meter. Okay. Now it is saying how fast is the stone moving before it hits the ground. When it hits the ground, what is the velocity, the total velocity? Remember, this has the horizontal velocity v0x, and this has the vertical velocity vy, and the total velocity is the vector shown. Okay, so we need to find out this velocity vy here, and let me erase this portion here. Maybe I can use here. In y direction, in y direction. Okay, along y direction. What I'm going to use is v is equal to u plus g times t. My goal is to find this velocity, the vertical velocity vy, when it hits the ground. What is the initial velocity? When I say the initial velocity, this means the initial velocity along the y direction. And we know that initial velocity along the y direction is 19.15. 19.15 plus g is 9.8 and the time is 3.75. Just plug in all the information here and you will get the vy as 55.9 meter per second. Okay, so we calculated that, and this is the total, this is the velocity v here. I would call it v total. So the v total is simply equal to v0 x squared plus vy squared. v0x is 16.1 squared and vy is 55.9. Do this and you will get 58.2 meter per second. So this is your total velocity.